Hi class, this is today's lesson is still on potentiometer where we are going to study the uses of potentiometer again, and this is part 2. This is Puan Anita Raj teaching for physics from 6 Sem 2. Before we move on to understand the uses of the potentiometer, let's learn some basic concept or some prior concept that you have studied in your Form 5.
Just want to teach something about our basic concept here before we go to measure the internal resistance of a cell. Now let's understand this basic circuit class. We have an EMF, okay, which is EMF E and internal resistance small r, which is fixed to a external resistance capital R, and then we have a switch, okay. This is a basic circuit, and this is actually your flashback of what you have studied in your Form 5. Now we are going to study about the concept of this basic circuit by looking at two things, class. One is switch is open, another one is switch is closed. Okay, now our main point here is, I'm going to draw the circuit again here for switch open. Yeah, this is the circuit. This is the internal resistance which is fixed to a switch, and the switch is open. If I want to measure the voltage between this terminal and this terminal, I can fix to a voltmeter. Okay, so the concept says here, okay, this one is R and this one, there's a small R there, and then we have E. The concept says that the voltmeter will detect and gives you the reading of E. It will give you the reading of the EMF, which is E, if the switch is open. Okay, why? Because when the switch is open, there is no current flow. When there is no current flow, that means there's no internal resistance, and there is no voltage drop, and there is no voltage terminal. Okay, alright. So if I have under switch closed, I have the same circuit, which is EMF E, and resistance is capital R, and there's a internal resistance, but the switch is closed. Okay, so before I go to that particular concept of what the voltmeter will read the value, I just want to flashback something and study about this circuit. Now if you look at the circuit class, this circuit is total EMF of the circuit is equals to the voltage of the external resistance, which is VT, we call it as terminal voltage, plus with VD, which we call it as voltage drop. Okay, as the switch is closed, current starts to flow. When there is a current, then what happens is there will be a voltage between this terminal to this terminal. So this is called as voltage terminal. Voltage terminal is usually the voltage of the exterior circuit or outer circuit. Okay, and internal voltage drop is the voltage of the internal resistance which is inside the cell. Okay, so then we get VD is equals to IR, and we know VT is equals to capital I times with big R. Okay, again, voltage terminal is the voltage outside the cell, and voltage drop is the voltage that drops, that means lost inside the cell when the current starts to flow. Okay, so from here I substitute IR plus I small r. I get this formula which I know you all have come across before in your form 5. Okay, so then in this case I also can copy back the formula, divide with capital IR, divide with capital IR, then IR is actually voltage terminal, which is VT. I get this one is 1 plus R over R. I can also make into this equation, which is a relationship between internal resistance with voltage terminal and also EMF. Okay, so this is what we understand of the circuit. Now let's look at what we can understand when we want to measure from this voltage from this terminal to this terminal. We can fix to a voltmeter. So when the switch is closed, class, the voltmeter will give you the reading of VT, okay, which is the voltage terminal. Voltage terminal is lesser than the EMF of the battery. The loss of the voltage is because of the internal resistance. Okay, so this is a very important basic concept before we go to potentiometer. Now, as we know, to use a voltmeter to measure from this point to this point only gives you an approximation value. We want accurate value. So what do? We can use a potentiometer. So that will be the next video.
Potentiometer is used also to measure the internal resistance of a cell.
To measure the internal resistance of a cell, internal resistance of a battery or a cell. When a cell of EMF E and internal resistance small r is connected in series with an external resistor of resistance R, the relationship between the potential difference V across the resistor, which is terminal voltage, ER and small r is, they give you the formula here, but they symbol the formula as V. Terminal voltage they symbol as V. So it goes back to this concept here, which I have taught you all. Okay, alright, so they are talking about this formula, alright, in the first point. Okay, so now what happens, class? What happens now? We know if a voltmeter, we use voltmeter, we only get an approximation value. So what we can do is to get an accurate value, we can fix this basic circuit to a potentiometer. So you will get this diagram. Okay, alright. So this is an example of, you can see here two diagram. Okay, this one is an example of it's connected to a voltmeter, and this one is to a potentiometer. This is called as primary circuit. This is called as secondary circuit. Okay, this is primary, this is secondary circuit. Okay, so how do we do this? How we want to measure the internal resistance of a cell? Okay, first thing, switch is open. When switch is open, okay, we slide the slider until galvanometer point 0. Then the voltage of this point to this point is balanced with the voltage from this point to this point. Therefore, the voltage this point to this point is directly proportional to the balance length L1. And this voltage from this point to this point is actually E. So I can say E is directly proportional to L1. Okay, alright. So switch is open. Now switch is closed. Okay, switch is closed. Alright, so what happens, class? Move the slider until you find the balance length. Okay, you slide the slider until you find the balance length, which the book has labeled L2. Okay, then you know that you slide the slider until you get the balance, you slide the slider until galvanometer points to 0. Then the voltage between here and here is balanced with the voltage between here and here. And therefore, the voltage here and here is directly proportional with L2. But who is the voltage between here and here? It is voltage terminal. Because switch is closed, so therefore it will measure voltage terminal. Okay, so here I get 1, here I get 2. Okay, so therefore E over Vt equals to L1 over L2. And from previously we know that E over Vt also equals to 1 plus R over capital R. So this one is number 3, this one is number 4. And 3 over 3 equals to 4, you get 1 plus R over R equals to L1 over L2. So R over capital R, okay, you just solve the maths here. And you get your formula to measure the internal resistance of a cell. This is how you measure the internal resistance of a cell. Okay. Alright. So the most important concept is when the switch is open, what does the potentiometer will read? The potentiometer will actually read the EMF of the battery. Okay. When the switch is closed, the potentiometer will read the voltage terminal. Okay, because there will be a voltage drop inside the cell due to the internal resistance. Alright, so the value of Vt will not be the same as the value of E. It will be lesser than E. Value of Vt will be lesser than E if there is internal resistance. Okay, alright, that's all, class. Okay, thank you.
Other than that, potentiometer can also be used to compare resistance.
Compare resistance, class, we can use potentiometer to compare resistance. We have this as a primary circuit, which is the potentiometer. Primary circuit, okay, and then we have this as a secondary circuit. Okay, so what I'm going to do is I'm just going to study little bit on this secondary circuit here. Okay, so I'm going to draw separately. Okay, this is X, this is Y, and this is Z. This is R2, this is R1, and from here to here is V1, from here to here is V2. Okay, then from this I know that from this point to this point, we know that V1 is equals to IR1. From this point to this point, we know that V2 is equals to IR2. So this is the secondary circuit. Okay, now we take the secondary circuit, we connect it to the primary circuit, the potentiometer, to measure to compare the resistance. We want to compare the resistance. So what do? The first thing is we connect this particular terminal Y to A. Okay, for the first one, yeah. and then we connect this particular point Y with the galvanometer to this point here, to the slider. Okay, and then we slide the slider until galvanometer points to 0. So when galvanometer points to 0, that means this voltage here is balanced. So therefore we can know that from here we can know that V1 is directly proportional to L1, number 1. Okay, V1 is X to Y. Okay, then next what we do is take another color. Alright, then we take this point here, point Y, we connect it to A, and then this terminal Z here, we connect it to a galvanometer, to a slider. Okay, then we slide the slider until galvanometer points to 0. Then what do we get? The voltage here, V2, is directly proportional from here to here, will be L2. So I can say V2 is directly proportional to L2. And V1 is IR1, directly proportional to L1. V2 is IR2. Okay, and this is number 3, number 4. We divide 3 and 4, we get R1 over R2 is equals to L1 over L2. So this is how we compare resistance by using a potentiometer, by using the length of the potentiometer. Alright. Okay, this method of comparing resistance is especially accurate for comparing only for low resistance. Only for low resistance. Why low resistance? Because when the pointer of the galvanometer points to 0, no current flows in the wire connecting the resistor to the potentiometer. Hence, the resistance of the connecting wire does not affect the result. It's actually in your textbook in point number 5. Okay. Alright, so class, you notice now, when once we know the working principle of potentiometer, our secondary circuit can change. The important is the concept remains the same. So what is the concept? The concept is V is directly proportional with length, balance length. Okay, alright, that's all class. Thank you.
Now, when we have already studied the concept, let's try to apply the concept. So please look at your reference book, Oxford FAJAR, turn to page 125 and read example 15.11.
Example 15.11 class. Okay, in example 15.11, you turn to page 125. In the circuit diagram shown, the length of the slide wire is 100 cm. So I'm going to write the information here. The length of the slide wire is 100 cm, which is the length from A to B. Okay, and its resistance is 10 ohm. There is a resistance in the wire which is 10 ohm. Okay, and R1 is 5 ohm, R2 is 15 ohm. E is an accumulator of EMF 2 volt, 2 volt with negligible internal resistance. Okay, alright, so this is example 15.1. Okay, alright, now it says when both switch S1 and S2 are open. When both switch S1 and S2 are open, the galvanometer G is balanced when the length AJ is 61.5 cm. So when both S1 and S2 is open, it says that the galvanometer G is balanced and the length AJ is 61.5 cm. So this is open. Okay, I made it two here because I want to see one open and one close. Okay, so this is open, both switch is open. So when both switch is open, it says the length AJ is 61.5 cm. Okay, and it said the galvanometer is balanced, so that means it is open here. So the value that will be detected here will be E1. So E1 is directly proportional to 61.5. Okay, so that will be number 1. And then we know that VAB is directly proportional to 100 cm. Okay, alright, so this is number 1, this is number 2. Alright, and then this one is also open. So when this is open, class, what will happen is the current will pass through here, and then you can have current flow in the resistant R2. So R2 will be affected. So we can use a potential divider formula, which is VAB is directly proportional to 10, because there's a resistance in AB which is 10 ohm here, and then E is directly proportional to 10 plus R2 is 25, because R2 is 15, and then here is 10, so 10 plus 15 is 25. Okay, so VAB, this one is number 3, this one is number 4. Correct? So we solve number 3 and number 4 first. We get VAB equals to 10 over 25 times with E. E is 2 volt. Okay, so what do I get? 10 times 2 divided by 25. So I get 0.8 volt. 0.8 volt VAB. But we haven't finished yet. We are supposed to find what? We are supposed to find the EMF of the cell E1. We are supposed to find E1. So therefore, from this, E1 is equals to 61.5 over 100 times with 0.8. So I get my voltage as 0.492 volt. Okay, so this is for A. A is supposed to find E1. Question A. Okay, let's look at question B. They ask us to find the internal resistance of the cell E1. Okay, internal resistance of the cell E1 means there is an internal resistance here. That means the switch would have been closed. Okay, now let's look at the next sentence in the question. When both S1 and S2 are closed, the balance length AJ is 10 cm. That means both are closed. And the balance length AJ is 10 cm. Okay, so how do we going to do this? Is that we know when it's closed, length AJ is directly proportional to the voltage terminal, which is VT. Correct? Okay, alright. And then we also know that VAB is directly proportional to 100 cm. Okay, this is number 1, this is number 2. Then number 3, we have to use a potential divider formula. Okay, so the first one will be VAB is directly proportional to 10 ohm. and then E is directly proportional. Okay, when the switch is closed, the flow of the current will be towards here. Okay, alright, so that means it will also be 10 ohm here, because it will not pass through R2. Alright, okay, so what happens here is VAB will be equals to 10 over 10 times with E, which is 2, so VAB equals to 2. Okay, alright, so now we already got this. Now from this we already got this. Now from this we are going to get VT. Okay, so LAJ is 10 divided VAB is 2. I'm using these two formulas, yeah, equals to VT over 100. So VT is 10 times 100 divided by 2. Okay, 10 times 100 cm divided by 2. Oh, that one is so huge. Okay, again, see, let me see. LAJ is 10 cm, VAB is 2. Oh, sorry. Okay, LAJ is 10 over 100 cm. Okay, because this one is length, this one is length, so this length is over this length. Okay, is equals to VT over VAB. VAB is 2, so VT is equals to 20 divided by 100 cm. So 20 divided by 100 will be 0. VT is 0.2 volt. Okay, so we already got VT, but we're going to measure the internal resistance which is inside here. So now we separately see the whole circuit. Okay, this is the whole circuit. This is R1. Okay, R1 is 5 ohm. This one E1 is 0.492 volt, and then we have voltage terminal is 0.2. So VT is equals to IR. VT is 0.2 IR. So I is equals to 0.2 divided by 5, which is 0.04. So the current flow is 0.04. So then we use E is equals to I R plus small r. I is 0.04, R is 5 plus R, and we have E is 0.492, which we got it from the beginning here. Okay, so 0.492 divided by 0.04, okay, minus 5. So we get R as 7.3 ohm. Okay, R is 7.3 ohm. Okay, alright, so we have already done the first and the second question. So let's look at the next question. The next question says the balance length AJ when S1 is open and S2 is closed. Okay, so I'm going to take this portion here, or I think I better just turn this next page and I just draw again. It says the balance length AJ when S1 is open and S2 is closed. So that means this is open, fixed to a galvanometer. This one is S2 is closed. So this one will be the resistance. S2 is closed. Okay, S2, and this is S1. This is E1, this is R1, and this one is E, this one is A, this one is J. Okay, alright. Okay, so they want us to find is the balance length AJ. Okay, let's do this together. Alright, so once this is on, the reading of the voltage of the potentiometer will give you the reading of those EMF. So E1 is directly proportional to length AJ. Okay, and VAB is directly proportional to 100 cm. Alright, and then this is number 1, this is number 2. Then we use a potential divider. VAB is directly proportional. VAB, the resistance is 10 ohm, so we put that 10 ohm. And then E is directly proportional. Okay, this one is closed, so the current will flow okay, alright, so E is directly proportional to also 10 ohm. So VAB is equals to 10 over 10 times with what is E? E is 2. So times with 2. So we get 2 volt. Then we bring these two together. We solve. E1 over 2 length AJ over 100 cm. Okay. Alright. So what is E1? We already know the value of E1. The value of E1 is 0.492. Okay. So 0.492 divided by 2 equals to length AJ over 100. So we get 0.492 times with 100 divided by 2. Okay, so we get our answer is length LAJ is 24.6. Okay, 24.6 cm. Okay, alright. Now next question. The next situation, it says length AJ when S1 is closed and S2 is open. Again, I'm going to draw a diagram. Okay. They say what? S1 is closed. This one is closed. Okay. Fixed to a galvanometer. Okay. This one is A. This one is J. This one is B. This one is E1. And then they said the S2 is open. So that means macam ni lah. Okay. Okay, let me fill up this one. This is E1. This is R1. This is S1. This is S2. This is R2. Okay. Now, the potentiometer, when this is closed, the potentiometer will read the reading from this point to this point will be the voltage terminal. So, voltage terminal is directly proportional to length AJ. Okay. And then we also know that VAB is directly proportional to 100 cm. Okay. Alright. And the next one is we use, this is 1, this is 2. Now we use the concept of potential divider. This is a potentiometer concept, yeah. Okay, then we use a potential divider concept, which is VAB is directly proportional to, what is the resistance of AB? 10 ohm. And E1 is directly proportional, so the current will start flowing this one. Okay, so R2 is taken into account and R2 is 15. So 10 plus 15 is 25. So VAB is equals to 10 divided by 25 times with 2. So I get 4 over 5, which is 0.8. Okay, then I already use this concept. I got VAB. Now I go to this two concept. Okay, So VT is equals to length AJ over 100 times with 0.8. Okay. Alright. Oh, sorry. We're supposed to find what? We're supposed to find balance length. So we're supposed to arrange length LAJ equals to VT times 100 divided by 0.8. Okay, now we want to know what is VT. Alright, so let's look at this circuit alone. Okay, let's look at this circuit alone, which is this circuit. Because there's a current flow there. Okay, so I'm going to just draw the circuit here separately. E1, this is R1, this is switch is closed, sorry, switch is closed, and then we have S1. Okay, so current flows, okay, and then there's the internal resistance. Okay, E1, there's the internal resistance. Alright, so we want to find VT. Now how do we do that? We know E1 is equals to VD plus VT, and we know E1 is 0.492 equals to VD plus VT. Okay, and we know this now from our calculation. The internal resistance is 7.3 ohm. Alright, so 0.492, we get I R plus small r. So we get I is equals to 0.492 divided by resistance R1. Resistance R1 is 5. So 5 plus with 7.3, R1 is 5, right? R1 is 5, doesn't make sense. Internal resistance is greater than the resistance. Okay, anyway, we just do the question. We get I as 0.04. Okay, alright. So then VT is equals to IR 0.04 times with 5. I get, so calculator dependent, 0.2 volt. Then I substitute this with 0.2. My answer I get is 25 cm. So length LAG will be 25 cm. Okay, alright, so that's how I solved my whole entire concept. I didn't even use any of the formulas that I've studied. I just used the concept. V is directly proportional to L, V is directly proportional to R. Same goes to this. I also use V equals to directly proportional to L, and then V directly proportional to R, and same goes to this situation. So the only thing you have to remember is your concept. You know your concept, you know the technique. Whatever question or whatever diagram is thrown before you, you can solve it. Okay, so that is about example 15.11.
Let's try and do another example. Now let's turn to page 127 from your reference book Oxford FAJAR and read example 15.12.
Example 15.12 in page 127. The circuit diagram below is used to determine the resistance R of a resistor. The balance length AJ is 36.5 and 58 cm when the terminal X is connected to Y and then to Z. Okay, when the terminal is connected to Y, the balance length, okay, is 36.5. When it's connected to Z, okay, then the balance length will be 58 cm. Alright. Okay, now let's look at the first one. What we are going to do here, Now what they ask us to solve is if the slide wire AB is 100 cm long. Okay, this one is 100 cm long. What is the value of R? Okay, when the first thing, when X is connected to Y, okay, so the voltage between here to here, if this is I, okay, so here will be V equals to I 50, correct? So I can say that 50I is directly proportional to length AJ, which is 36.5 cm. Number 1. Okay, I can also say that, is there a resistance? There's no resistance. I can also say that VAB is directly proportional to 100 cm. Okay, and since there is no resistance here, okay, so E1 is also equals to VAB. I'm studying the circuit, yeah, before I'm answering the question. Now when it is connected to XZ, okay, the balance length is connected to XZ, so what can I get? This whole potential from here to here, okay, from here to here, the potential will be 50 plus R I. I use the formula V equals to IR, correct? And they are in series. V is equals to IR. They are in series. So I 50 plus R. V is directly proportional to 58 cm. Number 2. Okay, sorry, this one I can put number 2. This one I can put number 3. Okay, now the question asks us if the slide wire AB is 100, what is the value of R? Okay, so we're going to find the value of R. Okay, 1 divided by 3. 50I over 50 plus RI is equals to 36.5 divided by 58. I and I cancel. So 36.5 divided by 58 is 0.629. So I just solve this. Okay. Equals to 31.47 plus 0.629 R. Okay, so 50 minus 31.47 is 18.53 equals to 0.629 R divided by 0.629. I get 29.45 R. I get 29.46 ohm. Okay, so this is how I solve. Okay, how did I solve, class? First, I connect to XY. So the potential difference here is directly proportional to the length here. Then after that, I connect it to XZ. The potential difference here is directly proportional to this length, which is the new length, which is 58 cm. So it must be somewhere around here. Okay, the new length AJ. Then I make into equation. I only use number 1 and number 3. And I can solve and get my R. Okay, so that is how.